Okay, thank you for tuning in. I'm Dave Goki. In this video, you will see how to complete assignment J6. This is an 8-step assignment to compute the expressions for 3D surfaces, space curves, functions with 3 variables, points, tangent and normal vectors, and planes, all using CalcPlot3D. The question you answer with this video is how to do all these 8 steps, and it started for me with watching the professor's instructional video a whole bunch of times in order to better understand the problem. Fortunately for me, the expression used in the instructional video bears a lot of resemblance to the expression I'm assigned to work with. On the right-hand side of the screen, you're looking at the finished product in CalcPlot3D. It shows an inverted paraboloid, a point on the paraboloid representing x, y, and z sub 0, 2 parabolas on the surface and planes that are orthogonal, and vectors and planes that are tangent to the paraboloid at that point. Referring first to sub 0 and 1, the expression in this assignment is 1 minus x squared minus y squared, with initial values for x and y of -1 and 1/2, which gives a value of z sub 0 of -1/4. This point is the big blue dot on the paraboloid. This is about the only part of this assignment that was easy to understand how to do. Step 2 calls for graphing a plane and a space curve, assuming y sub 0 is equal to -1. The plane is an expression of z is equal to 1/4 minus t squared. It's on the xy plane, a quarter point below the origin. And the space curve is x sub t is t, y sub t is 1/2, and z of t is 3/4 minus t squared. Step 3 calls for plotting a tangent vector at t is equal to x sub 0. This vector has a direction of 1, 0, 2 and starts at the point -1, 1/2, -1/4. This is the blue vector. Step 4 calls for fixing x to x sub 0 and then write the parametric curve 1t f of 1, t. The plane is 1, t, -t squared, and the space curve is x of t is 1, y of t is t, and z of t is t squared. This inverted parabola lies on the surface of the paraboloid on a plane that is at a right angle to the plane. That parabola x of t is t, y of t is equal to 1/2, and z of t is equal to 3/4 minus t squared is on. Step 5 calls for writing a vector tangent to the curve at t is equal to y sub 0. The direction for this vector is 0, 1, -1, and the point again is -1, 1/2, -1/4. Step number 6 calls for plotting a vector normal to and is the cross product of vectors 102 and 0, 1, -1. Plugged into MATLAB, this cross product is a vector with direction -2, 1, 1. Step number 7 calls for, with a lot of really ugly algebra, plotting a plane from the normal and the point. The resulting planar equation is 2x minus y plus 2 1/4. The plane is red on one side and light blue on the other side. Please note that I forgot to plot this on the submitted assignment, so please note it is there now. And in the final step, step number 8, the normal vector is plotted with a direction of 2, -1, -1. And that is how this assignment was completed. Thank you for watching.